Hi there and welcome to Mr.Azeez Maths. I'm Mr.Muhammed Azeez. I'm doing math videos. In this video we are going to solve this A-level past paper. It's paper 1 that refers to pure math 1. This is February-March 2021, paper 1 that has 1 hour 50 minutes. And while we are solving, we depend on the formula list MF19, which is right here. It will be provided with the paper. It has some rules that we are going to use. This paper has 1 hour and 50 minutes. So we begin with question 1A that has 1 mark. Find the first 3 terms in the expansion in ascending powers of x. Ascending powers of x means we are going to write 3 terms with x power 0, x power 1, x power 2, which are the first 3 terms. In order to expand this in the MF19, there is the rule we need. This is the rule. So we need the first term power n plus combination from n to 1, 1 minus n. Okay, we got the rule. Okay, this is going to be 1 power 5 plus combination from 5 to 1, 1 power 4, x power 1. The 2 powers together must add up to 5. Plus combination from 5 to 2, 1 power 3, x power 2. Now let's expand this. 1 power 5 is equal to 1 plus combination from 5 to 1. We can do this on calculator. In the calculator you need to press shift and division to get the C. So we write the first number 5, then shift division 1. It's equal to 5, so it's 5. 1 power 4 is still 1. 5 times x is 5x plus 1 power 3 is 1. 1 times x squared is still x squared. Then combination from 5 to 2. So we press 5, shift division 2. This is 10. So that's 10x squared. We got the first 3 terms in ascending power of x. Part B, we're going to do the same thing, but this time we have 1 minus 2x power 6. Find the first 3 terms in the expansion in ascending power of x. So we're going to do the same thing. 1 power 6 plus combination from 6 to 1, 1 power 5. It's very important to give little brackets for the second term. It's power 1. 1 plus 5 is 6. Always check. Avoid these simple mistakes that cause huge problems. 6 to 1 power 4 and negative 2x power 2. 2 plus 4, 6. Okay, these are the first 3 terms. To simplify this, 1 power 6 is still 1 plus combination from 6 to 1 is 6. Then 1 power 5 is 1. Sorry, 1 power 5 is 1. 6 times 1, 6 times negative 2, that's going to be negative 12. Negative 12 x power 1. And here combination from 6 to 2. Do these by calculator to avoid mistakes. Okay, this is 15. Okay, 15. Let's record this. This is 15. 15 times 1 is still 15. This power 2 will go to both because we have 2 terms. They are connected with multiplication. Then the power will go to both. Negative 2 squared is 4. So we have 15 times 4 and x squared. That's going to be 60x squared. 15 times 4, 60. It's positive. That's why I write plus. Look, I write plus or minus based on the result of the numbers that I multiply them by each other. Then here I get a positive result. I write plus 60x squared. Here I got a negative result because combination from 6 to 1 is 6 times negative 2 is negative 12. These are the first three terms. Okay, in part C, hence. Whenever you say hence, it means you have done something before this question. Then you're going to use these results instead of doing this all from scratch. That takes time. Then we have this, which is 1 minus 2x power 6. We want the coefficient of x squared. Then x squared happens between these numbers, because the digit after that has x power 3. We don't need that. The one after that has x power 4. We don't need them. So we need these. 1 minus 12x plus 60x squared. We need this to be multiplied by the expansion of this we did in part A. It was 1 plus 5x plus 10x squared. 1 plus 5x plus 10x squared. Now let's do this multiplication. We have two brackets. Each bracket has 3 terms inside. So we're going to multiply all of them by 1, multiply all of them by negative 12, multiply all of them by 60. Let's write the result. 1 times 1 is 1. 1 times 5x is positive 5x. 1 times 10x squared is positive 10x squared. This is for the 1. For the negative 12x, we multiply this as one term by all of these 3 terms here. Negative 12x times 1 is negative 12x. Negative 12x times 5. So negative 12 times 5. Negative 60. Negative 60. Okay, this is between the negative 12 and 5. Then x times x is x squared. And negative 12 times 10, this will be negative 120. And x times x squared is x cubed. Now for the last term, 60x squared. 60x squared times 1 is positive 60x squared. If we multiply 60x squared by 5x, we will get x cubed, which we don't need. And if we multiply 60x squared by 10x squared, we will get x power 4, which we don't need. And similarly, we don't need this term. Now we just work on the terms that make x squared. We don't need this term as well. We can simplify them and finally write the coefficient of x squared. This is what we need. Then it's fine to ignore them because there is no more multiplication to produce other x squares. Now let's work on these. 10x squared. Actually, negative 60x squared cancels 60x squared. What's remaining is positive 10x squared. The coefficient of x squared is 10. This is the answer of part C. If we want to quickly check the answers to save your time. Okay, question 1A, we got 1 plus 5x plus 10x squared. B, we got 1 minus 12x plus x 60x squared. And for C, we did this multiplication, and then at the end we got 10. So the process and the final result both have marks. Question 2. By using a suitable substitution, solve the equation. So when a question asks about substitution, don't try to solve it without substitution. Don't ignore that. Okay? They asked this, they have purpose for that. They want you to use substitution. Then do it. Look at the equation. We see this 2x minus 3 here made the equation hard. So let's let 2x minus 3 squared equal to y. We can do it without the square. We can do it with the square. Okay? Both lead to the same answer. Why I write the square with it? Then here it will be too easy to solve. I will have y and y here. Okay, let's rewrite the equation. Substitute in place of 2x minus 3 squared y. Then we will have y minus 4 over y minus 3 equals 0. Okay, in order to solve this, we need to have common denominators or multiply everything by y to avoid this denominator, to get rid of it. Then if we multiply everything by y, it will be y squared minus 4 minus 3 y equals 0. Now it looks like a quadratic equation. Let's rearrange it and solve it with calculator. Y squared minus 3y minus 4. We just replaced them. We didn't take any of them to the other side. That's why their signs are the same. Equals 0. Now in the calculator, you go to mode. Then in the mode we go to number 5, equations. And then in equations we want ax squared plus bx plus c equals 0. This is what we have. Then press 3. We enter only the coefficients. So there is no number in front of y squared. It means it's positive 1. Then negative 3 equal negative 4. So the solution is 4, negative 1. So y equals 4 or y equals negative 1. Then we solve them. Where? Here. We use this again. So y is 4. It means 2x minus 3 squared is equal to 4. So to get rid of this power 2, we square root both sides. Then this power 2 will go away. And this side, the square root of 4 is 2. This is very easy to solve. Okay, 2x minus 3 is equal to 2, so 2x is equal to 5. Then x is 5 over 2. Okay. Or, since it's squared, then we have two options. One of them is this, option I. We take it as positive, because if this bracket be equal to 2, then 2 squared is 4. But if this bracket be equal to negative 2, then negative 2 squared is also equal to 4. So be careful about the two possible answers. Is equal to negative 2, and then 2x is equal to 1, x equals 1 over 2. These are the two possible values of x, and we used substitution. So see, the substitution is like this, and the final answer is 1 over 2, 5 over 2. We got them both correct with some easy steps. Okay, this question. Solve the equation tan theta plus 2 sine theta over tan theta minus 2 sine theta equals 3, and the solution, the value of theta must be between 0 and 180. There is no equal under the inequality signs, then we don't include 0 or 180 if we got them in our solution. We ignore them. Now to solve this, let's copy it first and see what we can do. What can we do here? We can rewrite the tan theta as sine over cosine. If you forgot that, you can find it in the formula list MF19 that tan is equal to sine over cosine. You can find it in the trigonometrics part. Or if you can find some trigonometric identities here, you can use them if the identity makes the equation easier, because it's given, it's true. Okay, I'm going to write tan as sine over cosine. Plus 2 sine theta all over sine theta over cosine theta minus 2 sine theta equals 3. Nothing changed, only instead of tan we wrote sine over cosine. In fractions, if there is a fraction in the numerator or denominator or in both of them, if you want to get rid of the denominator, it's totally fine to multiply one side by this denominator, cosine theta, cosine theta. It's like we multiply this fraction by this fraction, cosine theta over cosine theta. And cosine theta over cosine theta is equal to 1. So it means we also multiply this by cosine theta over cosine theta. But immediately these two cosines cancel each other. That's why we don't even write them. In this side, some simplification happens. Then this cosine, when we multiply it by this fraction, the denominator will be cancelled. Then it will be like this, sine theta, because the denominator is cancelled, plus cosine theta times 2 sine theta, it will be 2 sine theta cosine theta over, same thing happens in the denominator, but instead of plus is minus, sine theta minus 2 sine theta cosine theta. Now you might wonder, equal to 3, why we cannot just cancel tan with tan, sine with sine, and the sine will be equal to -1. No, it's not possible. Whenever you see a term is next to plus or minus, you cannot just cancel this term with some term in the denominator, okay? It's impossible. But if this term is connected with this term with multiplication and this one with multiplication, then they all can cancel each other. But with addition and subtraction, you never cancel terms. Okay, let's continue. Now there is no fraction here or there, just one big fraction on this side, and under this 3 we have 1. We can follow cross multiples to get rid of this fraction at all, and we get an equation that we can work on. Then 1 times this, the numerator stays the same, sine theta plus 2 sine theta cosine theta is equal to, the denominator will be multiplied by 3, so it's 3 sine theta minus 2 times 3, 6 sine theta cosine theta. Now we are going to send all of these terms on the right to the left to make the side equal to 0, and the solution process will be easier. Then 3 sine theta, when we send it to the other side, it becomes negative 3 sine theta. Then, and we have sine theta here. It's positive with negative 3, it will be negative 2 sine theta. Then when this negative 6 sine theta cosine theta goes to the other side, becomes positive, it will be 6 sine theta cosine theta. And there's 2 together will be 8 sine theta cosine theta. Okay. And this side, nothing left, it's equal to 0. Now we see sine theta here, it's a common term. We can take it outside the brackets to factorize. Then negative 2, 8 is also divisible by negative 2, so we take the 2 as well. Then negative 2 sine theta is common. What's remaining here is 1 minus 4 cosine theta equals 0. Because the sine is outside, we took it as a common term, and negative 2 is also out, then we divide the 8 by negative 2, it will be negative 4. Okay, when we have some cases like this, we have two terms multiplied by each other, and the result is 0. It means one of them must be 0 or both of them. Then the case of this multiplication of these two terms is 0, then we say negative 2 sine theta could be equal to 0. That's why this multiplication is 0. Then this negative 2, we can say divide both sides by negative 2, then it leads to sine theta is equal to 0. And to get theta, we use inverse. Then shift sign is sine inverse of 0 brings theta. Theta is also 0. From this, we get the first possible value of theta, which is 0, but it should be ignored because it's outside the given domain. 0 is not in. Okay, then we go to the second option, which is this bracket might be equal to 0. Then 1 minus 4 cosine theta is equal to 0. What does that mean? It means 4 cosine theta is equal to 1. To get rid of the 4, we divide both sides by 4. Then we get cosine theta equals 1 over 4. And to get theta, we just use calculator. Shift cosine brings cosine inverse. Then we enter 1 over 4. Close the bracket. The answer, my calculator is in radian, as you see this little r here. This question, the domain is given in degrees, so it means we need to use degrees. Then to change calculator from radian to degree, you press shift mode, then you see this rad. You press 4 if you want to use radian, you press 3 if you want to use degree. Now this little d indicating that I'm programmed in degrees. Then again, cosine inverse of 1 over 4 is equal to 75.522. It's written on the cover of the paper that when you work on angles, give your answer to one decimal place. Then that would be 75.5. Theta equals 75.5. Done. And 75.5 is between 0 and 180. It is satisfying this inequality. That's why we accept this answer. Okay, question 4. Question 4. Find k. So when a question says find k, don't think straight away this question is very hard. No, there must be some evidence that help you to find k. Okay, a line has equation y equals 3x plus k, and a curve has equation y equals x squared plus kx plus 6, where k is a constant. Find the set of values of k for which the line and curve have two distinct points of intersection. So whenever you see this expression, two distinct points, you straight away think about when we work on these two equations, there must be b squared minus 4ac greater than 0. Now let's work on them. Since they intersect, we set them as equal. Then 3x plus k is equal to x squared plus kx plus 6. How I straight away set them as equal? Because this side is y, this side is y, and it's obvious that y is equal to y. If this is 2y or 3y, then we need to make y the subject, then equalize the right side of both equations. Now, luckily, y is equal to y. We don't need to do that. We straight away start solving. Okay, to solve this, I see x squared, then I know I have to make a quadratic equation, and then to be able to solve a quadratic equation, it should be equal to 0. Okay, then I'm going to send these two terms here to the other side. The 3x becomes negative 3x, and k becomes negative k, and since nothing will remain here, it will be 0. X squared plus kx plus 6, it's better to write than do the work. Minus 3x minus k. It was positive, it's negative. It was positive, it's negative. Now it's all right. Then simplify. X squared has no any like term, stays as x squared. Kx and negative 3x, they have x in common, so we can say plus k minus 3x. Then 6 is a constant, and the question said that k is a constant, so we can make them one term to represent c, plus 6 minus k, and it's equal to 0. Now, since I have a quadratic equation and there is two distinct points of intersection, it means I straight away work on this inequality. B squared, whereas b is the coefficient of x, and the coefficient of x is this bracket, so the whole bracket is representing b. A is the coefficient of x squared, since there is no any number, it means it's positive 1. And c is this combination of two constants. Let's do it. X minus 3 squared minus 4 times, this 4 is in the rule, 4, a is 1, we don't need to even mention it because 1 times anything stays the same, then 6 minus k. Now I have b squared minus 4, a is 1, don't need to write, c. b squared minus 4ac must be greater than 0. I just solved this. Look at this inequality. How many unknown terms are there? Only k. So I made a mistake here. This x must be k. See? If in a single inequality you see two unknown terms, it means this inequality cannot be solved. It either does not have solution or it has infinitely many possible solutions. Then one inequality, one unknown term, yeah, good to go. Expand. To expand a squared bracket, you either write it twice, you multiply manually, or I use this first term squared. 2 times first times second, so it will be 2k times negative 3, it will be negative 6k. Second term squared plus 9 minus 4 times 6 is 24. Be careful, this minus is for both, it's negative 4. Then negative 4 times 6, negative 24. Negative 4 times k is positive 4k, greater than 0. Now let's simplify the like terms together. K squared has no any like term, stays as k squared. Then negative 6k and 4k will be negative 2k. 9 minus 24, 9 minus 24, these are the places where you make silly mistakes. Negative 15, greater than 0. Then we solve this by calculator, or you can solve it with the quadratic formula, which is provided in the MF19. Go to mode, number 5, number 3, then enter the coefficients. K squared has no number in front of it, which is 1, then negative 2, then negative 15, press equal, so k is 5, negative 3. So since we want this side be greater than 1, then k is greater than 5. K is greater than 5 and k is less than negative 3. So we go outside of this range. This is how you solve quadratic equations. If you want the quadratic expression be greater than 0, we go outside the two numbers we get. So how can we go out? Like from negative 3 to 5, how can we go out? We go out if we pick numbers greater than 5, and we go out if we pick numbers less than negative 3. But if we want the quadratic expression be less than 0, then we take only inside, and we never write equal with them. Never. And if we want this be equal to 0, then these are the two possible solutions that make it equal to 0, not greater or less. Now we have the case of expression greater than 0. Then we go outside. Outside means case that are greater than 5, case that are less than 3. That's how we go out. We got two possible sets of values of k. This is where we stop. We don't go anymore. Question 5. So some transformation happened on this graph, and let's see what do they ask for. In the diagram, the graph of y equals fx is shown with solid lines. Okay, it's clear. The graph shown with broken lines, talking about this, is transformation of y equals fx. Okay, so this one is the original shape, this is the image. Describe fully the two single transformations of y equals fx that have been combined to give the resulting transformation. Okay, what happened? This minimum point, or this turning point, has moved to the right. How many steps? So if we count from middle to middle, it's 1, 2, 3, 4. So this point moved 4 steps to the right. So in the description you just write this. Y is translated 4 steps to the right, or 4 units to the right. Okay, this is the first transformation that happened. The second transformation, after it's been translated to the right, if you look at this graph, it's stretched. How is the stretch? The width of the graph is still 2 squares, then it means some vertical stretch happened. Then the second transformation is a vertical stretch, scale factor 3 or stretch factor 3. How? before, from this point to this corner was taking 1 unit. Now from this point to the first corner on the left takes 3 squares. Then the second transformation, I don't have space to write because I need to explain it on the graph, but I said the answer. The second transformation is a vertical stretch or stretch parallel to y-axis, stretch factor 3. Then this question says describe. Then we described. State in terms of y, f and x the equation. So this time we need to write the equation in an algebraic form. So y equals fx. We said it's translated 4 steps to the right. Then translation 4 steps to the right will happen with the x. So y will be equal to f of x minus 4 because it's translated 4 steps to the right. If it's to the left, we add. Then a vertical stretch. A vertical stretch is simple. We just write it here. Scale factor 3 or stretch factor 3. Vertical stretch, we just multiply the whole equation by the scale factor. But if it's a horizontal, we just multiply it with the x. And for a horizontal stretch, it's the opposite. For example, if some horizontal stretch is a stretch factor, if the graph is 3 times greater than it was, then we write 1 over 3 here. Where it was vertical, vertical is simpler. Now we used y, yes, f and x. Yeah, we did. This is the description in an algebraic form. Question 6. It's a question related to rate of change, rate of increase or rate of decrease. They're all the same. So these questions could be very tricky, while if you do it right, it's pretty easy. Let's see what we have. dy dx is 6 over 3x minus 2 power 3. And a point is given, 1, negative 3, lies on the curve. A point is moving along the curve and at A. The y coordinate of the point is increasing. See, y increasing, it means y changes. Then this sentence tells you dy dt. dy dt is 3. This is the key. Y increases, it means y changes. Then this is dy dt, it's equal to 3 units per second. Why I write dt here? Dt stands for time, and this 3 is per second. Then this is dy dt equals 3. Okay. Find the rate of increase at point A for x. It means you need to find dx dt. It's unknown. Okay, we have a rule that connects dy dt, dx dt, and dy dx, which is chain rule. Chain rule is provided in the formula list MF19. Yeah, dy dx is equal to dy dt divided by dx dt, or times. Okay. dy dt, what is the dy dx as number? As number, dy dx, we just substitute this 1, which is the x value, in place of this x, and then we get dy dx as number. dy dx is equal to 6 times 3 times 1 minus 2 power 3. 3 times 1 is 3. Minus 2 will be 1. 1 power 3 is still 1. So it is 6. dy dx is 6. Now let's just write the chain rule. dy dt is equal to dy dx multiplied by dx dt. This is unknown, but we know dy dx and we know dy dt, it was given. Then 3 is equal to 6 times dx dt. 6 times which number will be 3? So it's obvious, or 3 divided 6 is 1 over 2. So dx dt should be t as it was here. Then dx dt is equal to 1 over 2. That's it. Too much information, so many writing. No, we don't need them. We just need these numbers, and the result of rate of change is a number, not an equation, in most of the cases. Find the equation of the curve. So since the curve is not given, but the derivative of it is given, 6 over 3x minus 2 cubed. 6 over 3x minus 2 cubed. This is the derivative. How can we get the actual curve back? By integral, because integrals are antiderivatives. Then we will just have to solve integral 6 over 3x minus 2 power 3 dx. Then to solve this, it's easier to send the 6 outside of the integral and bring this bracket from denominator to numerator and change the sign of the power. Then it will be 6 integral bracket 3x minus 2 power negative 3 dx. In order to be able to integral this, we need to have the derivative of inside outside. The derivative of inside the bracket is 3. Then we need a 3 outside. And to keep the balance, we add 1 over 3 outside the integral. Now we are ready. Since we have the derivative of inside outside, we can just say the bracket as it is. Power plus 1 over new power. And 1 over 3 times 6 will be 2. So 2 times this bracket, don't forget, plus c. Basically, 2 cancels 2. What's remaining is negative 3x minus 2 power negative 2 plus c. We can use the point A to find c. Since we know a point, we cannot leave it as c. Then we use this point. The point is 1, negative 3. The point is 1, negative 3. The first entry is x. The second entry is y. Now, what was that? This was dy dx. It means the derivative of y. Now, after the integration, it's just y. Then we replace y by negative 3 and x by 1. Negative 3 is equal to negative 3 times 1 minus 2 power negative 2 plus c. Look at this equation. The only unknown term is c. It's solvable. Then negative 3 equals 3 times 1, 3 minus 2, 1. 1 power negative 2 is 1. But don't rush. 1 to the power of negative 2. It's equal to 1. Now we are sure. This will be 1 plus, and this negative is still here. What is C? C is negative 2. C is equal to negative 2. So the curve is this. So y equals, it's not simplest form to have negative power. So we send this to the denominator, then the power becomes positive again. Negative 1 in the numerator, 3x minus 2 squared, and we found C, it's negative 2, then we write minus 2. This is the curve. When you solve, make your answer clear, like I did all of these working outs. I don't leave it here. I need to give an answer, final answer. Okay, functions. Functions f and g are defined as follows. F is x squared plus 2x plus 3, while x's are less than negative 1. And g is 2x plus 1, while x's are greater than negative 1. Then express f in the form of x plus a squared plus b. Whenever you see this form, it's completing square. So completing square, let's copy the expression, x squared plus 2x plus 3. In order to write this in a completed square, we write x, same sign here, plus half of this number, 1 squared. This is the first step. Second step, whatever we write here, this number, we write it outside as minus, always, okay? It has nothing to do with this sign, or the sign. Next to the squared bracket is always minus this number squared. And this plus 3, we just copy it down. Then we simplify it. It's x plus 1 squared. And 1 squared is 1. Negative 1 plus 3 is plus 2. Now f has this form. State the range of it. So we can find the range by using this. Okay, since x is less than or equal to negative 1. So negative 1, it's less than or equal to negative 1. If we write negative 1 here, by the way, when we use completing squares, this is going to be the minimum value. This is the minimum. Then range of f is y greater than or equal to 2. Because this bracket can be 0 by writing negative 1 in place of x, then negative 1 plus 1 is 0, what's remaining is 2. So this expression can never be less than 2. It could be 2, but it cannot be less than 2. Then this is the range. This part done. Secondly, we need to find f inverse. Let's make sure about f. To find f inverse, we can use this, or I suggest always when you have a quadratic equation and you are required to find its inverse, write it in the form of completed square, then find the inverse, and I'm going to tell you why. X squared, so f is equal to x plus 1 squared plus 2. f is equal to this. Why we need to use completed square? Because in completed square we have only one x, but if we use this x squared plus 2x plus 3, since we have two x's, it's going to be very confusing to get rid of them, to make y the subject again, and you'll see why. Okay, this step 1, to find inverse, we just replace x by y, so x is equal to y plus 1 squared plus 2. Now the actual inverse happens when we make this y the subject again. Then in order to make this y the subject, firstly we get rid of this 2. It will be x minus 2 equals y plus 1 squared. Then to get rid of this power 2, we square root both sides. Then this side will be under square root, and this power 2 will be removed with the square root. What's remaining is just y plus 1. To get rid of this plus 1, we just say minus 1 to the other side. Then x minus 2 all under square root minus 1 equals y. Now y is the subject, this is the inverse. So f inverse x is equal to square root x minus 2 minus 1. This is f inverse. Solve equation g f x equals 30. gf means write f in g in place of x. What is g? G is 2x plus 1, and f is x squared plus 2x plus 3. Again, we can use the completed square form of f, and it's fine to use the f as it's given in the question. fg means write f in g in place of x. Then gfx is equal to, it's not multiplication, it's not like g multiplied by f. No, it's composite function. Then g is 2f plus 1. What is f? So gfx is going to be 2 times x squared plus 2x plus 3 finished, and then this plus 1. Let's get gfx. Then after simplification we set this as equal 13, then we solve. It's going to be 2x squared plus 4x plus 6 plus 1 plus 6 plus 1 is plus 7, and then we say this is equal to 13. So 2x squared plus 4x plus 7 equals 13. And to be able to solve, we need to send 13 to this side and becomes negative. (2x squared plus 4x plus 7 minus 13 negative 6 equals 0. Now we solve it by calculator or by quadratic formula. 2, 4, negative 6, 1, negative 3. So x equals 1 or x equals negative 3. We got the answers. Question 8. The points A, B, C are on the circumference of a circle. Find the equation of the circle. So let's illustrate what we have. A rough sketch will help a lot. The points we have, let's say 1, 2, 3, 4, 5, 6, 7, and the largest y we have is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we roughly sketched 3 points. 7, 1, 7, 1 is here. This is A. 7, 9, 7, 9 is here. This is B. 1, 9, 1, 9 is here, and this is C. It looks like a rectangle. If we need, there's another point. It's 1, then here. If we need, maybe we don't need. Okay, from A to B, from point A to point B, the y values, this is 1, this is 8, it means this is 1 by 9, it means from A to B is 8 units. From A to B is 8 units. From B to C, C has x value 1 and B has x value 7, so from C to B is 6 units. So it's a rectangle, and each corner is on the circumference. What does that mean? In order to write equation of circle, we need to know center and we need to know radius. Center and radius. Okay, then since the shape is rectangle and you know the diagonals of rectangle cross in the middle. Diagonals of rectangle cross in the middle. This middle is midpoint of A and C. We can use the rule of midpoint. You can find it in MF19, or if you can memorize. Midpoint of, now I'm going to find midpoint of A and C. It is, add them, divide by 2. 7 plus 1, 8, divide 2, 4. 1 plus 9, 8, divide 2, 1 plus 9, 10, divide 2, 5. Then I got the center. Now I need the radius. If this point is the center and this point is on the circumference, then this distance is going to be radius, or this distance, A to the midpoint, or B to the midpoint. Then we use the rule distance between 2 points. Then if we call this midpoint M, then the distance from C to M is equal to, actually it's the radius, is equal to square root C and this point. Okay, I can say 4 minus 1 squared plus, since I said 4 minus 1, I must say 5 minus 9. I cannot say 9 minus 5. Four minus 1 is 3. 3 squared is 9. Plus 5 minus 9 is negative 4 squared is 16 under square root, and it's going to be 25. Square root of 25 is 5. Now I know center and radius. The equation will be easy. First number goes with x, second number goes with y, then x minus 4 squared plus y minus 5 squared equals, we can write 5 squared or we can write 25. Both are correct. Now this is the equation of that circle that passes through these 3 points. Find an equation of the tangent to the circle at B. The equation of the circle was like this: x minus 4 squared plus y minus 5 squared equals 25. Let me just give it a quick check. X minus 4 squared, y minus 5 squared equals 25. This is the equation, and point B, just copy it and don't come back to this page. 7, 9. Okay, to find equation of tangent, we need to use this: y minus y1 equals slope or gradient x minus x1. Then 7 is x1, 9 is y1, y is a variable, x is a variable, so what we need is only gradient. And gradient is derivative. Gradient is derivative at a point. Then let's find the derivative here. The derivative will be gradient. Then derivative here, we need to find y prime or dy dx. Okay, first derivative, let's expand them first. We can do it even without expanding. Power goes to the front, 2 bracket as it was, power minus 1 times the derivative of inside. Derivative of inside is just 1, we don't need to write. Same thing happens here. Power goes to the front, bracket as it was, power minus 1 times derivative of inside. Derivative of y is y prime, but derivative of x is 1. Be careful about this. And equal to derivative of 25 is 0. I do this to find derivative, to find y prime, and y prime at a point will be gradient. That's why I do this. Now I want to make y prime the subject after I substitute x by 7 and 9 in place of y. Then I'll have 2 times 7 minus 4 plus 2 times 9 minus 5, y prime stays, equals 0. 7 minus 4 is 3, times 2 is 6, plus 9 minus 5 is 4, times 2 is 8, but this 8 is not a normal 8, it's 8 y prime equals 0. To make y prime the subject, then this 6 goes to the other side, becomes negative, and then we divide by 8. Y prime equals negative 6 over 8. That simplifies to negative 3 over 4. They are both fine. Now I have the gradient. I just have to rewrite this to be the equation of tangent line. Then y minus 9 equals negative 3 over 4 x minus 7. Question doesn't say give the equation in the simplest form, doesn't say anything, we can leave it like this. Question 9 is about progression, is cosine theta. The first term in a progression is cosine theta. Theta is between 0 and pi over 2, or if you work in degrees, it's between 0 and 90. For the case where the progression is geometric, the sum of infinity is 1 over cosine theta. Show that the second term is cosine theta sine square theta. For progression questions, the first thing you need to write is the rule. What's given? This is sum to infinity. Let's find sum to infinity in the MF19. Okay, geometric series, sum to infinity. So S infinity is A over 1 minus R. What does that mean? It means A over 1 minus R. This is S infinity. We have A. A is the first term. And okay, we will find R. We will find R in this equation that we are going to solve. And then why we need R? Because in geometric progression, first term is A, second term is AR, third term is AR squared. In general, it's ARN minus 1. This is UN. Okay, we need to find R. Then A is cosine theta over 1 minus R equals 1 over cosine theta. Why? This is the sum to infinity, which is given. And this is the sum to infinity according to the rule. And they are equal because they are both the sum to infinity. Then we solve this. The only unknown thing we have is R. We want to write R in terms of cosine. Okay, to make this R the subject, we can just multiply the two fractions like this, cross multiples, because on both sides we have a single fraction. This is one way. You can multiply both sides by cosine, then this cosine will be cancelled. This cosine will be squared and this one will be cancelled. Then again, we can solve. We can make R the subject. Then cosine times cosine is cosine squared theta equals 1 times 1 minus R is still 1 minus R. Then in order to make this R the subject, so we send this one to the other side. Cosine squared theta minus 1 equals negative R. R is not the subject because it's negative. Then we multiply everything by negative 1. Then it will be negative cosine and it will be positive 1. It's better to write like this. And it's fine to not write. It's fine to write negative cosine squared theta plus 1. But it's better to write like this. Then this is R. 1 minus cosine squared theta. What is the second term? Second term is AR. We had A cosine theta. It was given. And then R is 1 minus cosine squared theta. This is the second term. But this is cosine theta sine squared theta. If you go to the MF19, you see 1 minus cosine squared is equal to sine squared. So U2, which is the second term, is cosine theta sine squared theta. So that means it's correct. You just find a way. We did. It's all right. Now, double I. Find the sum of the first 12 terms when theta is 1 over 3 pi, giving your answer correct to 4 significant figures. Okay, in the MF19, let's look at the sum. Sum infinity was here. Sn, we can use this rule to find sum of 12 terms. Then S12, because we want to find the sum of the first 12 terms, is equal to A is cosine theta, and theta is 1 over 3 pi, times 1 minus, we found R, it was 1 minus cosine squared, which is sine squared. This one is in the rule, 1 minus R, and R is sine squared 1 over 3 pi. And this should be power 12. Over 1 minus sine squared 1 over 3 pi which is 1 minus r. Then since we have the theta, this will be number. They are all going to be numbers. And we give the answer to 4 significant figures. It's better to give it another step. Theta is 1 over 3 pi. It's obvious this angle is radian, it's not degree. So let's change the mode to radian, number 4. Okay. You can do this by pressing shift and mod. Okay, cosine 1 over 3 pi times pi. Sometimes calculator doesn't understand if you just write pi beside the fraction. Cosine, but why cosine 1 over 3 pi is 0.5. So this is 0.5 times sine squared. When something has 2 powers, we multiply the 2 powers by each other. Then this 12 will be 24. And it's 0.031. Then 1 minus the last answer is 0.968. So this is 0.968. 968. That's why I told you it's better to give it a step. Don't enter this, all of it, into the calculator and get one final answer at once. Okay, finally we have sine squared 1 over 3 okay, we can use this squared. Sine 1 over 3 pi is already entered. Squared is equal to 0.75. Then 1 minus the last answer, which was 0.75, is 0.25. Now let's enter this to the calculator and give our answer to 4 significant figures. Let's use fraction. 0.5 times 0.968 over 0.25. The answer is 1.936. It's already 4 significant figures, which is 3 decimal places in this case. 1.936. To avoid that, you can write more decimal places here, because this is the only place that we can write more decimal places, and then we will get more decimal places here. Okay, this one done. For the case where the progression is arithmetic, the first 2 terms are again cosine theta, cosine sine square, respectively. Find the 85th term. Okay, 85th term. Firstly, let's look at the formula list, and this is for arithmetic. Un is a plus n minus 1d. Let's write this. Un is a plus n minus 1d. D is the difference between first and second term, or any 2 consecutive terms. Okay, we want to find u85. Let's see what's missing. Equals a, we know it's cosine theta. And theta is 1 over 3 pi, so it's going to be cosine 1 over 3 pi plus n is 85 minus 1. D we don't know. Let's find D. D is equal to second term minus first term. Cosine theta sine square theta minus cosine theta. We can just use it like this. We can simplify it. Since we know theta is 1 over 3 pi, don't waste time on simplifying. Just use it like this. D, so this bracket, which is 84, will be multiplied by this. Cosine 1 over 3 pi sine squared 1 over 3 pi minus cosine 1 over 3 pi. This is going to be the 85th term equals cosine 1 over 3 pi cosine 1 over 3 pi is 0.5, so it is 0.5 plus 85 minus 1 is 84 times this bracket cosine 1 over 3 pi is 0.5, we worked out, sine we will work out minus 0.5. Now let's work out sine squared. Sine 1 over 3 pi, close the bracket, close the first bracket, power 2. This is sine squared, 0.75. It's multiplication, so times 0.75. It's a very good idea to give it a step, then write the final answer, which is a number. We have 0.5 plus 84 times bracket 0.5 times 0.75 minus 0.5, close the bracket, it's equal to negative 10. So U85 is negative 10. Next question is this. It's a combination of algebra and geometry. The diagram shows a sector ABC which is a part of a circle with a radius A. Okay. The point D, E, and E lie on AB and AC respectively, and such that AD is equal to AE in length, and it's equal to KA. K is less than 1. The line DE divides the sector into two regions which are equal in area. For the case where angle BAC is 1 over 6 pi radians, find K correct to 4 significant figures. Okay. Since the area of this triangle is equal to the area of this piece of the sector, then we set like an equation. Area of this triangle is equal to the area of the sector minus the area of the triangle. Then area of this triangle, since we know this angle, it's 1 over 6 pi, then we say area is 1 over 2 AB. AB, by AB I mean the two sides of the angle. They are the same, then AB, both are KA, KA, then it will be KA squared. KA squared like this. Without these brackets, we have to write K squared, A squared. Okay, 1 over 2 AB sine 1 over 6 pi. This is area of the triangle. And then 2 times this area, because area of this triangle is the same of the area of this piece, then 2 times the area of the triangle is equal to the area of the whole sector. If we multiply this by 2, it's going to be KA squared sine 1 over 6 pi is going to be a number. Let's work it out. And then we write the area of the sector. It's in radian, yes. Sine 1 over 6 pi is 0.5. So 0.5 is here, or 1 over 2 here. This 1 over 2 is not this 1 over 2. This 1 over 2 came from sine 1 over 6 pi, and this 1 over 2 is cancelled because we multiplied this by 2 to be the area of the sector. The rule of area of sector, it should be here. Yeah, area of sector is 1 over 2 r squared theta when we work in radians. So area of sector is 1 over 2 r squared theta. So it's going to be 1 over 2 a squared, and theta is 1 over 6 pi. 1 over 2 r squared theta is area of this sector. Now if we look at this, we can solve it. It's area of the triangle. Let's find some value of k. Let's find some value of a including k. Then to do this, the a squares cancel each other. We can find k here. This square will go to both. It will be 1 over 2, and if we multiply everything by 2, we will get rid of these two 1 over 2s, and this square is for both. It will be k squared a squared equals a squared 1 over 6 pi. Since it's an equation, if we divide both sides by a squared will be removed. Then k squared is equal to 1 over 6 pi, and k is the square root of 1 over 6 pi. Square root of 1 over 6 times pi. 0.7236. If we want to give the answer to 4 significant figures, that's 1, 2, 3, 4, then it will be 0.7236. K equals 0.7236. I needed the diagram, that's why I did the solution here. I didn't go down. For the general case in which angle BAC equals theta, not 1 over 6 pi, is given theta over sine theta is greater than 1. Find the set of possible values of k. Then we did this. Then here we keep 1 over 6 pi as 1 over 6 pi. We keep 1 over 6 pi as theta, and then we will get the general form. This is the area of triangle, 1 over 2 ka squared sine theta equals, then this thing times 2, because it's area of the triangle. If we multiply it by 2, this 1 over 2 will be removed, is equal to 1 over 2 r, which is a, r squared theta. This is the general form. Here again we want to make k the subject, and it will be k squared a squared sine theta equals 1 over 2 a squared theta. Then a cancels a, k squared is equal to 1 over 2, and the 2 goes down, a squared here, now a is removed, theta over sine theta. Because the a's are removed, if we divide both sides by a cancels a, then it will be theta over 2, the 2 is here, theta is there, theta over sine theta. then this is k squared. What about k? K is the square root of that. Theta over 2 sine theta. This is the general value of k. And theta over sine theta is greater than 1. Then we know this is greater than 1. So k will be complete here. This is greater than 1. It's given. Then on the side it will be square root of 1 over 2 is less than k, and it's less than 1 because k should be less than 1. We can also write this as square root of 1 is 1, square root of 2 will be decimal. We can write it as 1 over square root of 2 less than k, and it's less than 1. Okay, we did the general case and see the last question. The last question, here is a graph. The diagram shows the curve with equation y equals 9x negative 1 over 2 minus 4x negative 3 over 2. The curve crosses the x-axis at point A. So crosses x-axis means it's x-intercept, and in x-intercept y is equal to 0. So to find A, we just set y as 0 and we solve. 0 is equal to 9 x negative 1 over 2 minus 4 x negative 3 over 2. Okay, this side is 0. If we divide both sides by 9, 0 divided 9 is still 0, and this side divide 9, this 9 will be cancelled. It's equal to x negative 1 over 2 minus 4 x negative 3 over 2. And this is additional page. Thank you so much for watching. I hope you find it useful. Comment below whatever question you have.